Last section of chapter 10 is that we're going to find the area of circles and sectors. Now, the area of a circle we've already done in the past. It's just pi r squared. So I just want you to review real fast and do the got it question. So in the got it question, it says, what's the area of a circular wrestling region with a 42-foot diameter? In order to find this, I would need to find the radius. So I would divide it by 2. So my radius is 21. So on your calculator, you should be doing pi times 21 squared, which is about 1,385.4 square feet. The reason you have to do that is because we're going to find the area of a sector. So a sector is a section of the circle. So it's not the whole circle, okay? So we're going to find just a portion of it, and to do that, we had to use the area formula for a circle. Just like in 10.6, you were finding arc length, so that's why you use circumference. Now we're finding area inside, so that's why it makes sense to use the area formula for a circle. So what we're going to do is, first thing is, it wants us to find the area of the sector, so make sure you can see that you're finding this piece down here that's lightly shaded. We are not putting our answer in terms of pi, so you can scribble that out and put it in decimal form. So I need to do the measure of the arc AB, so that would be 72, divided by 360, and then I'm going to take it times my area formula. So that would be pi times my radius, which is 15, squared. I just type this into my calculator, so 72 divided by 360, and then make sure I'm timesing by that piece. So I end up getting 141.4 centimeters. Pause the video and see if you can do the got it question. So in the got it question, it says that I had a 45 minor arc, so I would do 45 over 360, take that times pi times my radius, which is 4, and then square it, and then my answer would be 6.3, and it should say square inches, just like up here it should say square inches. Okay, so not too bad, just making sure you're plugging stuff in the appropriate spots. The next part is where you're going to do a little bit more work. So I want you to find the area of a segment. So what that is it's taking just a small portion of your circle, like this piece here. So what you can do is, if you can find the area of the sector, so this big piece that I'm pointing to, and subtract away the area of the triangle that gets formed, then you just found the area of that small segment. So let's see what that looks like here. So here's my formula. I want to use area of a sector minus area of a triangle, and it wants me to find the area of the shaded segment shown at the right. Now again, if it's hard to see, darken in this area over here because that's what we're trying to find. So I need to do area of the sector. So that formula said I need to do the measure of the arc length, which is 60 since it's the same here, so I would do 60 divided by 360, and then I would times it by pi times my radius squared. So my radius was 18, so that's why I put 18 squared in there. Now you can go ahead and find that number, which I did, which is 169.6. Then we need to come back and we need to find the area of the triangle. Well, remember the area formula for a triangle is a half times base times height. So I have my base, which is 18, but I need to find the height. So do you remember when we were putting in that apothem, which you can draw this way if you prefer, but I just did it here since I know that this is 18. So you can draw in your height here.
Ray to the gym, please. Ray to the gym.
Apologize for the interruption. You can put in your height there, and then notice that it will split it in half, so that'll be 9, just like our apothem did, and then it'll also split this angle. Now how did I know that both of these were 60? Here's why. So if this radius is 18, this is a radius, so I know that that is 18. This is going to be isosceles. So if this angle is 60, I can subtract that from 180. So 180 minus 60 is 120. And then split that in half because these two angles had to be congruent since these two sides are congruent. So that's how I ended up finding that it was a 60-60 or equilateral triangle, equiangular triangle. So going back to finding your height, you want to, again, put in your apothem, and then we're going to use those 30, 60, 90 formulas in order to find what my height is. So this is going to split this side in half, so that's going to make this 9. This is my short leg, so all I have to do is take my short leg times square root of 3, and that'll give me my height. So that's where this 9 square roots of 3 came from. So those formulas that we used a while ago are coming back. Okay, so if you come back over to using your calculator, you plug all that in. I got 140.3. I plugged all that in. I got 169.6. I want to subtract away the triangle piece from my whole big sector, and that'll leave me with just that small piece. So that's how I end up getting 29.3 square inches. Okay, a lot going on there, so see if you can apply that formula to the last question. All right, last question here. I'm trying to find the shaded region, so if you can't see, again, it's that darkened region right there. It's kind of small. So first thing is using the first part. So I got 90 over 360, since this is a 90-degree angle, times pi times my radius squared, which is 4. So then that gave me 12.6 for the area of the entire sector. Then I need to subtract away the area of that triangle, so I do a half times base times height. Now you have to know what your angle measurements are so you know what's going in there. However, this is a radius of 4 from there, and this is also a radius, so no, this is 4. If this is a right triangle, I know that this is my base and this is my height. So all I have to do is do a half times 4 times 4 for the area of that triangle. So then I can subtract 8 from the 12.6, and you should be getting 4.6 meters squared. Okay, a lot going on in those last questions, so let me know if you need some more practice. Otherwise, go ahead and start on your assignment.